Yes. So, in the last session, in the last class, we have completed thermodynamic processes and we defined what is a reversible process and what is an irreversible process. So, reversible isothermal process, adiabatic process chusam. Let us discuss two more processes are there, isobaric process and isochoric process. Isobars, bar ante general unit for pressure. Iso means same, isobar means that is pressure constant process. Isobaric process. Isobaric process. So, in an isobaric process, so we keep the pressure constant. So, when we keep the pressure constant, according to the ideal gas equation, I can write, so volume will be is equal to NR divided by P into T. So, at a constant pressure and at a constant moles, volume is directly proportional to the temperature. ఏమంటారు దీన్ని గెలిజాక్ లా అంటారా చార్లెస్ లా ఏవో అవే ఉంటాయి కదా. సో వాల్యూమ్ ఇస్ లైక్ దిస్. నౌ వెన్ యూ సీ ద ఐడియల్ గ్యాస్ ఈక్వేషన్, కాన్స్టెంట్ ప్రెషర్ వీ హ్యావ్ డిఫైన్డ్ Cp. సో దట్ మీన్స్ dq కెన్ బి రిటన్ యాజ్ NCp dt. So when I treat Cp will be constant for a change in temperature, the dq can be written as NCp into T2 minus T1 అని రాయొచ్చు మనం. So this is what actually the dq. Then as the volume is changed and temperature is also changed, this work done will be, what is the work done will be integration P dV. So that is, we can write simply P into delta V, ఎందుకంటే P constant కదా. So that is P into, simply I can write V2 minus V1. If there is a graph of volume versus pressure, then here volume is changing from V1 to V2 by keeping pressure is constant. So pressure is neither increased nor decreased. The pressure will be remains constant pressure. Kabatti area under the curve ఏమవుతుంది, this multiplied by this. This is V2 minus V1 and this is P. That's why P multiplied by V2 minus V1 will be the area. So isobaric pressure will be remains constant. Okay. So as the volume is increased, then there is a change in the temperature. So there is a increase in the internal energy. So there is a mechanical work done as well as there is a change in the internal energy at constant pressure process, that we have already explained in the previous class itself. Cp enduku greater than Cv untadu annappudu. Okay, something like this. Now let us go for isochoric process. Isochoric process. Isochoric process means it is volume constant process. When I keep the volume is constant, then delta V is equal to 0 it means. So that means work done will be, so that is integration of P dV, as there is no change in the volume, whatever may be the pressure, that work done will be 0. So once work done by the gas is 0, the work done by the gas is 0, then what we can take from the first law of thermodynamics, delta Q is equal to delta U plus W. So from here delta Q is equal to delta U, that is plus W is 0. So the delta Q can be written as F by 2 NR into T2 minus T1. So volume constant process. So there is a delta Q. So that means I can write delta Q that is equal to delta U can be written as NCV delta T. That is T2 minus T1 and rastam. So as usual volume constant process kabatti pressure can be written as NR by V into temperature. This R is the gas constant. So as the temperature is increased, pressure is also increased. So these are the isochoric process. So work done with, and process ఏంటో డిఫైన్ చేసుకోవడం, then we need to see what is the first law, what is the ideal gas equation, దానికి ఏమైతే చూడడం అంతే. Then there is one of the important, something like free expansion. Free expansion, expansion into vacuum. So expansion into vacuum. So we can draw here PV diagram also. Then we can represent volume here and pressure here. Volume is fixed. That means pressure can be increased, pressure can be decreased, pressure can go from P1 to P2, but the volume will be constant. So indicator diagram is there. Now let us see free expansion. So consider ఏ అడియాబాటిక్ వాల్స్ ఉన్నటువంటి ఒక ఛాంబర్ తీసుకుందాం. లెట్ us take ఏ అడియాబాటిక్ వాల్స్ ఉన్నటువంటి ఒక ఛాంబర్. నౌ డివైడ్ ఇంటూ 2 ఈక్వల్ పార్ట్స్. Divide into 2 equal parts. Let us divide into 2 equal parts here. So now fill here ideal gas. I am filling only ideal gas. I said we are not taking the real gas. Let us fill with the ideal gas. So here the volume is V by 2, pressure is P, temperature is some T. Okay. So otherwise you can call it as something like V naught. Container volume, the pressure is P naught, temperature is T naught. Here it is vacuum. So we can define the volume for the vacuum, that is V by 2. And a chamber volume, container volume itself is gas volume, but there is no gas molecules there. So pressure 0, temperature 0 for an vacuum. Now remove that partition. Remove the partition. Somehow we remove the partition. What happens when I remove the partition? It is a free expansion. That means if I remove this, the gas molecules will go from here to here by themselves. So by the process of diffusion or effusion, whatever. So the process of diffusion, so they go from this regions to that region, the free. So we are not supplying any heat here. So without any supply. So then what we note is here, so volume will become V, pressure may be some P, so temperature may be some T. So now we need to calculate what is that. Volume will be double, you no need to mention here that volume will be double. Then V will become, that is 2 times of V naught. Then what is the pressure and what is the temperature? What is the pressure and what is the temperature? That we need to comment for this an ideal gas. For this ideal gas, temperature and pressure and comment. What is the pressure and what is the temperature? We need to comment here. Okay. Now, as it is a free expansion, that means as the gas is expanding from this place to this place, no need to do any work. అవి అక్కడికి పోవడానికి వర్క్ ఏం చేయనవసరం లేదు. Same heat లేకున్నా సరే they will go. So that means here delta Q is 0 and even there is no work done by the gas. ఇక్కడ ఎవరైనా ఆపోజ్ చేసేటోళ్ళు ఉంటే then there is an opposition కాబట్టి అది వర్క్ చేయాల్సి వచ్చేది. There is nothing to do. That is work done will be 0. As it is a free expansion, we are not supplying any heat. Then what first law gives? First law gives delta Q is equal to delta U plus W. Delta Q 0, W 0. So that gives delta U will be is equal to 0. That is F final is equal to initial. That is T2 is equal to T1. అంటే ఇక్కడ టెంపరేచర్ T0 అనుకుంటే ఇక్కడ కూడా మనకు టెంపరేచర్ ఏమొచ్చింది T0 అనే వచ్చింది. The temperature will be remains constant, that is temperature T is equal to T0. Temperature will be T0. Now let us look for the pressure. Then what will be the pressure here? There pressure P0 తీసుకున్నాం. Then what is the pressure? So temperature constant process. So remember, temperature constant process does not mean it is an isothermal process. Isothermal process is completely different. There the system where can supply the heat. Antena? So as the delta Q is 0, then you cannot say it is an adiabatic process also. It is not adiabatic process. So in that adiabatic process, the system can be reversibly possible. This can't be reverse process. So it is a one-sided game. It is a irreversible process. Even that to be, we cannot indicate any diagram here. Initial గా ఎలా ఉంటుందని చెప్తాం, ఫైనల్ గా ఎలా ఉంటుందని చెప్తాం. ఇక్కడ నుంచి ఇక్కడికి ఎలా వచ్చిందని చెప్పలేం. There is no rule between pressure, volume and temperature. Okay. Then ideal gas equation apply చేద్దాం. PV is equal to nRT. Number of moles constant, R constant, T constant. So PV is equal to constant. Pressure is inversely proportional to volume. So ideal gas equation apply చేస్తే నాకు PV is equal to constant. As the volume is double, pressure will become half. That is P0 by 2. Okay? The pressure becomes now P0 by 2. Okay? That's it. So this is the free expansion. We cannot express. There is no PV diagram for it. దీనికి ఏమన్నా ఒక PV diagram అంటే, so this is the volume here and this is the pressure here. This is the initial process, initial state, and this is the final state. But there is no curve which joins from initial to final. It is not possible. And end of process annadi. So of course, first of all, it is an irreversible process. But of course, irreversible process. అయినా సరే దాన్ని ఇండికేటర్ డయాగ్రామ్లో ఇండికేట్ చేయలేం. ఓకేనా? సింప్లీ there is a pressure, there is a volume, then what is the initial pressure, and then what is the, we can say initial pressure will be is equal to some ఏదో ఇక్కడ ఉన్నామా, initial pressure P0, final pressure P0 by 2, initial pressure P0, initial volume V0, temperature అనేది సేమ్. ఫైనల్గా ఇటుకు వచ్చాం, pressure became P0 by 2, volume became double 2 V0, and here it is P0 by 2. But what is that line? Straight line, curved line, itla line అనేది మనం చెప్పలేం. We can show what is the initial point on PV diagram, we can show what is the final point on PV diagram, but there is no curve, there is no relation which joins pressure and volume relation. ఆ relation అనేది రాయలేము ఇక్కడ. This is what actually the free expansion. Okay, so be careful. Note.